Hello everyone, this is Rashaka Janjarla. I'm an educator in Academy. You can follow me on Academy Learning app where you can find Mother course as well. In this lecture, we are going to solve an example problem which is based on the design of spiral springs. And please rate, review and share the video and also subscribe to Unacademy YouTube channel. So in the last lecture, we have discussed about the design analysis of spiral springs. And we have derived some of the formulas for the deflections and the strain energy and also the angle of rotation, and we have found the relation for the bending stress developed in the strip of the spiral spring, right? So now in this lecture we are going to solve an example problem which is purely based on the concept that we have discussed in the last lecture. Okay, so here we have the problem: a flat spiral spring used in an electrical instruments required to exert a maximum force of 5 newtons at the free end against the retaining drum. So the line of action of this force is 75 millimeters from the center of gravity of the spiral. So this is the distance from the center of the gravity and the line of action of the force that is applied here in this example. Okay, so the distance is R is given by 75 millimeters and the spring made of brass strip, and this brass has a modulus of elasticity of 106,000 Newton by millimeter square, and the maximum bending stress should not exceed 100 Newton by millimeter square. That means the maximum bending stress, which will be the permissible bending stress for this spiral spring. Okay, so the width and the length of the spring are given by 12.5 and 750 millimeters. So here we have the problem. So we have to calculate the thickness of the strip and the number of degrees of rotation through which the arbor should be turned to produce the required force. So we have the formulas for the thickness of the strip and also the angle of rotation of the spring, angle of rotation of the spiral spring, and the drum, the outer strip, which is called as the drum of the spiral spring with respect to the arbor, which is the central strip of the spiral spring. So now we are going to calculate these values, thickness and the number of degrees of rotation. So given in the problem, the maximum force acting on the outer end of the spring is 5 newtons, and the distance r from the center of gravity of the spiral spring to the line of action of the applied force is 75 millimeters, and the width of the strip is 12.5 millimeters, and length of the strip is 750 millimeters, and the permissible bending stress will be sigma b equals to 100 Newton by millimeter square. So with the help of the material properties, they have provided the modulus of elasticity given by E equals to 106,000 Newton by millimeter square. So with the help of this data, we are going to solve the problem. So see here, the force applied here at the outer end of this spiral spring, which is in this direction, and the distance from the line of action to the center of gravity of this spiral spring is given by 75 millimeters. So we have these values, and also the cross sectional the parameters of this spiral spring is also provided, that is width and the length, and also they have given the material properties, the modulus of elasticity. So see here, part 1, thickness of the strip. So the moment load acting on the spiral spring is given by M equals to PR, where P is the applied load at the end and R is the distance from the center of gravity of the spiral spring to the line of action of the spiral spring, right? That is 5 into 75, and on calculating this value, we have got moment load is equals to 375 Newton millimeters, and the corresponding bending stress developed in the strip of the spring is sigma b equals to 12m by bt squared. So we have derived this relation in the last lecture, right? So with the help of this, we can find the value of the stress. Here we have to calculate the thickness, right? So the value, this value should not exceed the value that is given here, that is the maximum bending stress, right? So on making these two values equal, we can get the critical value of the thickness of the spiral spring here. So we have the bending stress given by this formula, and the maximum permissible bending stress is given in the problem, that is equals to 100, right? So on making these two values, sigma b and the given maximum stress equal, we can get the value of the thickness, right? So on making this value, that is sigma b equals to 100, and on substituting the values of moment and the width of the strip of the spring, we have got this value 100 equals to 12 into 375 by 12.5 into t square, right? On solving for t, we can find the value of the thickness. So on solving for t, we have got t equals to 1.897 and it is approximated as 2 millimeters. So this is the process to find the value of the thickness of the strip. Here we have just made the value of the bending stress equal to the permissible bending stress, that is the maximum stress given in the problem. Okay, so with this relation we have found the value of t, the thickness of the strip. So next, degrees of rotation. So in the last lecture we have derived the value of the degrees of rotation, okay, and it is given by theta, and this is the angle. So we have found the relation for the angle, right? The angle of rotation made by the arbor with respect to the drum, right? So that is given by theta equals to 12 into ml by eb into t cube. So on substituting the value of t that we have obtained in the part 1 of this problem, and we have the value of m, the moment load acting on that spiral spring, and with the help of these two values and the modulus of elasticity and the width of the strip, we can calculate the value of theta. Okay, so this is the angle of rotation, and on substituting this value in the given problem in this equation, we have got theta equals to 12 into 375 into 750 by 106, which is the 000, which is the modulus of elasticity, and b, the width of the strip is 12.5, and t is the thickness of the strip. So with these values, on substituting these values, we have got the value of the degrees of rotation given by theta equals to this value 12 into 375 into this value, right? So and this value, so this relation is provide the values of theta in the units of radians, right? So to get the value of theta in degrees, we have to divide it with pi, and we have to multiply it with 180. So on multiplying with 180 and dividing with pi, we can get the value of theta in the units of degrees. So we have got the value of theta equals to 18.24 degrees. So this is the value of theta in radians, and this is the value of theta in the degrees. So this is the process to find the value of degrees of rotation of the arbor with respect to the drum of the spiral spring. So here we have used the relation for the theta, which is derived in the last lecture. Okay, so before coming to this lecture, you should know the design parameters or the design analysis of spiral springs. Thank you.